Hello student. In the last session we have discussed the term polynomial, then degree of the polynomial, then how to find the value of a polynomial at a particular point, then the graphical representation of what linear polynomial and a quadratic polynomial. So in this particular, it is a continuation part of that. So today we are going to discuss the second part, and thus we are going to learn the relationship between the zeros and the coefficients. Okay, so let's start it. So the quadratic polynomial is given by quadratic polynomial is given by ax square plus bx plus c. Here degree is what 2, so the number of zeros is what 2. So this you need to remember. So whatever the degree of the polynomial, that number of what zeros it will going to have. Okay. So particularly let me take it's a quadratic polynomial. So let me take the alpha and the beta are the two zeros of the quadratic polynomial. Then what is the first relationship between the coefficient? The sum of the zeros is equal to minus coefficient of x upon coefficient of what? X square. If you see carefully, the coefficient of x is what? B. So therefore it is written what? Minus B, and the coefficient of x square in this is what? A. So therefore it is what? A. The first relationship which we are going to get is what? The sum of the zeros of a quadratic polynomial is nothing but what? Minus b upon a. Similarly, the second relation is what? The product of the zeros is nothing but the constant term divided by the coefficient of what? X square. So here the constant term is what? C, and the coefficient of x square is what? A. So the next relationship is what? Alpha into beta is equal to what? C upon A. Now let's take some example so that you will understand it what in a better way. Okay, so here what is the question? Question says find the zeros of the quadratic polynomial and verify the relationship between the zeros and the coefficient. Okay, the first example which I have taken is what? X square plus 5x plus 6. So to find the zeros, what we do, we equate the given polynomial with 0. So you will get what? X square plus 5x plus 6 is equal to what? 0. If we compare this with the quadratic polynomial, the a will be what? 1, b will be what? 5, and c will be what? 6. You can easily compare it with the quadratic polynomial, which is what? Ax square plus bx plus c. So simple. Now what are you going to do? You need to do the factorization of the polynomial. Okay, so we'll do it by what? Middle term splitting. So the constant term is what? 6. So is 2 factor, so that their addition should be what? 5. It will be what? 3 and 2. Therefore the middle term, which is what? 5x, can be split as what? 3x plus 2x. Taking the common from the first two term, it is what? X. Remaining will be what? X plus 3. Similarly, common from the next two term is what? 2, and it will be what? In the bracket x plus 3. So common is x plus 3, and into x plus 2 is what? 0. So either x plus 3 is equal to 0 or x plus 2 is equal to what? 0. So you will get the value of x is equal to what? Minus 3 and minus 2. So simply whatever value you're getting for the x, they are what? Zeros of the given quadratic polynomial. So zeros are minus 3 and minus 2. So this is the first part where we need to find the zeros of the quadratic polynomial. Now further we'll check out the relationship between the zeros and the roots or the coefficients of the x and x square. So first is what? A alpha plus beta is equal to what? Minus b upon a. So this we need to verify. So consider the alpha plus beta, which will come out to what? Minus 3 plus minus 2, which is what? Minus 5. Now if you see right hand side, which is what? Minus b upon a, it should come out to what? Minus the value of b in this particular, the coefficient of x is what? 5. Therefore it is what? Minus 5 upon the coefficient of x square is what? 1. So it will be what? Minus 5 upon 1, which is coming out to be what? -5. So what are we finding? Ki alpha plus beta is nothing but what? Minus b upon a. So it is what? Hence we get the verification of the relationship. Now further we move for the other example. Okay, second part first. Okay, this was in that it was the first, which was the alpha plus beta. Now we have to go for the next relation, which is what? The product of the zeros. So product of the zeros is given by c upon a. So if we do the product, the roots was -3 and -2, so it is coming up to what? 6, and c की value क्या है यहाँ पे? 6 है, so you will get what? 6. So both side over, hence the relationship is what? Verified. Let's go for the next example. It's what? P square minus 3. This is given polynomial. To get the zeros, it's what? P square minus 3 is equal to 0. No need to go for any middle term splitting. Directly you can get the value of what? P. When I'm taking the root, so it is always plus minus, okay, of that particular number to the right side, okay. So it will be what? Plus minus root 3. So therefore the zeros of the given polynomial are what? Plus root 3 and minus root 3. So if I consider plus root 3 as what? Alpha, and another as what? Beta. So these are what? Two zeros. The relationship will verify. Alpha plus beta is given by what? Minus b upon a. So root 3 plus minus root 3, it is coming out to what? 0. So your coefficient of the p, because p is term coefficient, p term is what? Absent. So therefore the coefficient of p will be what? 0. So it's what? Minus 0 upon 1, which is coming to what? 0. So first relation is what? Verified. Now move for the next part. This is what? Product of the zeros, which is what? Alpha into beta. If we do, it will be coming out to be what? -3. Similarly, if we see c upon a, the value of c is what? -3 upon 1, so which is coming to be what? -3. So hence the relationship between the zeros and the coefficients is what? Verified. Similarly, we can go for the other example. Other example is what? X square plus 4x plus 4. Either you can go with the middle term splitting, or you directly use the identity which I have used over here. So this can be written as what? X square plus 2 into x into 2 plus 2 ka whole square. So it is coming into what? X plus 2 ka whole square by using the identity a plus b ka whole square. So what we are getting here, the power is what? 2. It means the zeros are what? Repeated, and they are what? The same number. So we get the value of what? X is equal to what? -2 and -2. So we can say the two zeros are what? -2 and -2. Okay. Now let's move further. So I can write alpha as what? 1, and beta as what? Alpha as what? -2, and beta as what? -2. Now relationship symbol, it's what? -2 and -2. It is coming out to be what? -4. And if we see the right hand side, it is what? Minus b upon a. The value of b is what? 4, and the value of what? A here is what? 1. Simple. So first relation is verified. Similarly, you can verify the product. It's what? Alpha into beta is equal to what? C upon a. So alpha is what? 2 -2, and beta is also -2. It is coming out to what? +4. And the value of c is what? 4, and the value of what? A is what? 1. So it is coming to be what? 4. That's all. Okay. Now let's do some question from the NCRT. I'm doing the first question. Question is what? Same. Find the zeros of the following given polynomials, and then verify the relationship between the coefficient. So now to get the zeros, equate the given polynomial to what? 0. When you equate it to 0, again by middle term splitting, constant term is what? -8. So it can be split into two terms as what? -4 and 2. Okay. So this can be written as x into x minus 4 plus 2 into x minus 4 is equal to what? 0. So simply it's a simple calculation. Take the common, and you will get the value of x is equal to what? 4, and x is equal to what? -2. So you can take either one as alpha, or other as what? Beta. So I'm considering alpha as what? 4, and beta as what? -2. So relationship क्या होना चाहिए हमें यहाँ पे? Alpha plus beta is equal to क्या होना चाहिए? -b upon a. Simply do the calculation. Simple. Alpha is what? 4, and beta is what? -2. Simply if we do, so 4 minus 2 is what? 2. Simply b की वैल्यू क्या है यहाँ पे? -2 है, और a की वैल्यू क्या है यहाँ पे? 1 है. देखिए यहाँ पे केयरफुली देखेंगे, यहाँ पे समझ में आ जाएगा. तो 2 और 2 सेम हो गया. सिमिलरली वी कैन गो फॉर द अल्फा इंटू बीटा. तो अल्फा इंटू बीटा इज व्हाट 4 इंटू -2, वो कितना होगा -8 होगा. यहाँ पे कांस्टेंट जो है वो कितना है आपका 8 है. कांस्टेंट कितना है यहाँ पे 8 है. ठीक है. सो यहाँ पे कांस्टेंट -8 है. सो -8 upon 1. सो अगेन the both side are what same, so we can say this relation is also verified for the given polynomial. ठीक है. Now move for the next. Let's take the another example which is saying it's a 4s square minus 4s plus 1. Now to get the zeros, equate the polynomial with 0. Either you can go with the middle term splitting, or if identity is applicable, you directly use the identity. Here identity is applicable because I can write this as what in the form of what a square minus 2ab plus b square, which is equal to what a minus b ka whole square. So simply you will get it as what 2s minus 1 ka whole square. Okay. Now further, when you equate with the 0, so you will get alpha as what 1 by 2 and beta as what also 1 by 2. Again simple relationship is what sum of the roots is nothing but what minus b upon a. So sum of the roots is what half and half is what 1. So you getting 1. Now minus b upon a. So b की वैल्यू यहाँ पे क्या है, it's about coefficient of s which is what -4. Okay, so it is what minus into minus will become plus, and 4 divided by 4 is what 1. So left hand side relationship is what the sum of the coefficient is what verified. Now go for the product is again half into half is what 1 by 4, and C is nothing but what 1 and A is what 4. So directly it is coming to be what 1 by 4, 1 by 4, 1 by 4 is equal. So this relation is what verified. Okay. Similarly, you can go for the third question of your NCRT. The given question is what 6x square minus 3 minus 7x. Okay. Be careful while you're writing the polynomial. Always write in the decreasing power of the x. You have to arrange this particular question first of all. So I have arranged this. This should be what 6x square minus 7x minus 3 is equal to what 0. Now to get the zeros, we do the middle term splitting. Number is what 8 minus 18, because you have to do the multiplication of the constant term and the coefficient of x, which is what 6. So 3 into minus 6 is what minus 18. So you need to get the two factors of minus 18 so that their sum should be what -7. So I got this as what two factor is what -9 and plus 2. Remaining is what simply getting the factors. The first factor will be what 2x minus 3. Another factor will be what 3x plus 1. So when you solve this, you will get the value of x is equal to 3 by 2 and x is equal to what -1 by 3. So these are the two zeros of the given polynomial. So I can consider the first as what alpha and another as what the beta. And further we will verify the relationship between the coefficient. So what is the first relationship between the coefficient? That says कि sum of the roots is what minus b upon a. So move further. So alpha is what 3 by 2 and beta is what -1 by 3. So when you simplify left hand side, you will get what 7 by 6. Now if we go for the right hand side, it is what minus b upon a. So minus the value of b is what -7, and the value of what coefficient of x square is what 6. So it is what minus of -7 divided by what 6, which is coming out to be what 7 by 6. So simply this relation is what verified. Now for the product of the zeros, alpha into beta is should be what c upon a. So alpha is what 3 by 2, beta is -1 by 3. So when you simplify, it is coming out to be what -1 by 2. Similarly, right hand side, the value of c is what -3 and the value of a is what -6. Sorry, 6. So it is coming out to be what -3 by 6, which is what -1 by 2. So hence both sides are the same. So relation is what satisfied or verified. Okay, go for the next question. This is the fourth question of the first question. So given question is what, it's a 4u square plus 8u. So now to get the factors, we equate this polynomial with the 0, and when we equate, we get this equation. Now to get the factors, the first rule is always look for the common factor. See here, what is the common factor? It's a what 4u. So I will take 4u outside and remaining terms that will as it is. So it will be what, u plus 2. So when I equate with the 0, either 4 cannot be 0, so u must be 0, or u plus 2 is what, 0. So you will get two zeros. One is what, the 0 itself, and another is what, minus 2. So I can consider alpha as what, 0, and beta as what, minus 2. Now to verify the relationship, first relationship is what, alpha into beta, which is what, minus b upon a. So alpha is 0 plus minus 2 is what, minus 2. The value of b here is what, 8, and the value of a is what, 4. So it will be what, minus 8 upon 4, which is coming out to be what, minus 2. So the first relationship is what, verified. Now go for the product is what, alpha into beta is equal to what, c upon a. Alpha is 0, so 0 into anything is what, 0. So you will get 0 to the left hand side, and the value of c, because the constant term is absent, so when constant term is not there, it's about 0. So 0 divided by 4 is again 0. So this relationship is also verified. Fifth question, t square minus 15. This kind of question I've given in the simplification also. When I've taken the example based on the relationship, you can easily do this question. Okay, let's move to find the zeros, equate the given polynomial with the 0. Now I can change this 15 minus 15 to other side, so it becomes what, plus 15. So the value of t will be what, plus minus root 15. So two zeros of this are nothing but what, plus root 15 and minus root 15. So you get the what, two zeros. Now you have to check for the relationship. It's quite simple. I'm taking it quite a little bit fast here now, because this all is a repetition of the same thing, and it is what, very easy to understand now if you understand the concept. So alpha plus beta is what, root 15 plus minus root 15. It's coming out to be what, 0, because the middle term was not there, so the coefficient of x will be what, 0. So the b will be what, 0. So again 0 divided by anything is what, 0. So first solution is what, justified. Okay, now move for the product. It's what, alpha into beta is equal to what, c upon a. So alpha is what, alpha is what, root 15, and beta is what, minus root 15. So when you do the multiplication, it will be what, minus 15, and if we go for the c upon a, the value of c is what, minus 15, and the value of a is what, 1. So it will coming out to what, minus 15. So this relationship is also verified. Now go for the next question. This is sixth question and the last question of question number 1. Now first, before you see the solution, please pause it and try it yourself. Okay, let's move. Take it to get the zeros. First of all, we equate the given polynomial to 0. So when I equate 0, middle term splitting is about coming out to be what, first of all the constant term will be what, minus 12, because minus 4 into 3 is what, minus 12. And if it take the factors to split the middle term, so it is what, minus 4 and 3. So 3, so you will get what, minus 1, which we require here. So middle term will be what, minus 4x plus 3x. So when you take the common from the first term, it's x as a common, you will get what, 3x minus 4 plus, nothing is common, so 1 is common, so you will get 3x minus 4 in the bracket itself. Factors, you will get these two factors. When you equate with the 0, the one value of x is what, 4 by 3, and another value is what, minus 1. So these are the two zeros. So take first as what, alpha, another as what, the beta, and check this relationship. So it's a 4 by 3 plus minus 1. So it is coming out to be what, 4 plus minus 3 upon 3, because when you take the LCM, you have to multiply and divide it by what, 3. So you will get this, and you will get the left hand side is what, 1 by 3. And here the coefficient of what, x is what, minus 1. So it is coming out to be what, minus of minus 1 upon 3. So this relation is what, verified. Now move for the next, alpha into beta, which is what, c upon a. So it's a 4 by 3 into minus 1, which is coming to what, minus 4 by 3, and the value of c is what, minus 4, and a is what, 3. So this relation is also verified. Hope so you have understood all these questions. In the next part, we will learn how to get the polynomials if we know the zeros of the polynomial, quadratic polynomial, or we are given with the sum of the zeros and the product of the zeros, or different another information by which we can get the what sum of the zeros and the product of the zeros. Then how to find the equation of polynomial we will learn in the next session. Thank you very much for watching this video. Please, if you like my video, like it, subscribe it and share it among your friends. Thank you very much.